Okay, so we are going to talk about just some of the concepts behind chance experiments and events. Um, Main thing, you need to just understand about sample spaces and about events within the sample spaces. So uh, let's consider like a two-child family. Let's look at the order of which the children could be, and the composition of the two siblings. Pretty simple to understand. So we've got the first child. So for the first children, you could either have a boy or a girl. Okay, that's what we have. So that's how we split them. Now, sometimes we would put the probability of such next to them for calculation purposes, but we're not going to do that right now. Well, the second option, for the second child, we would do another branch from there, and each of those could be a boy or a girl, a boy or a girl. So at the end of the tree, we follow the branch. So if we go down the boy branch and then down the next boy branch, we have two boys, which is a possibility. But if we're going down the boy branch but go to the girl branch second, we would have a boy and then a girl. Now, if we follow the girl's first branch, we could go girl and then a boy, or we could follow all the way to the end to the girl-girl option. Now, our total sample space here, which is what we're looking for, all the possible options, is going to be boy, 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 girl, girl, boy, and girl, girl. So anytime we're looking at any type of probability, we've got to understand the whole sample space, because that is going to be our denominator. Any event that's in there, that we're looking for the probability of, we would divide that number by our sample space. So it's important to be able to create a probability tree to kind of understand all the possibilities so that we can create an entire sample space. Now, when we look at the connection of events and the probability of events, um, oftentimes it makes a lot of sense to think about things in terms of a Venn diagram. Um, well, if we look at this, our sample space is the entire box. So that is the whole box filled all the way up, all the possibilities involved. We then have event A, which is represented by the white circle. Well, event A is everything inside this. Okay, everything. Event B is everything inside this B circle. And what you can see, though, is that they actually overlap each other. So there are events that are in both A and B. Now, every event occurs in S. So if it's in S, then we know that if it's in event A or in event B, it is obviously possible, or it has to be in our sample space of possibilities in order for it to be in there. So let's look at some different options here. Now, we could say event not A, or A complement. Sometimes you'll see it as, or A bar, something like that. Or you can see it as A complement, or just called not A. This is every event that isn't in A. It cannot be in A. So let's look, so that would look something like that, right? Basically everything inside the white circle is now filled in. So that is going to be what event A complement or not A is going to be. It's the same idea for event not B. So this is everything outside of A. So that's the same thing for B. So I won't do that multiple times. Now, we could have event A union B. So what this means is A or B. So anything in A or anything in B is included. So what we'll be looking at here is everything in A, and then everything also that's left over that's in B. So you see how that covers all the circles and their intersections in the middle. So that's got more to it. Now, if I have event A intersect B, now this is only events that are in A and B. So if I were to fill up this entire circle in different parts, just like this is A union B. I need to remove all the possibilities that are in A but not in B. So if it's not inside the B circle, then I have to get rid of it. So I get rid of this section. And also, anything that's in the B circle that is not also in the A circle is eliminated as well. So I'm left with the intersection or the overlap of the two. So make sure that you understand that union means or, which means there's more possibilities. And also make sure that you know that intersection means and, which is less, because you have to have two things occur at the same time. Now, one possibility that you'll see, and one thing that's very important, is this idea of disjoint or mutually exclusive events. These are events that don't share any common outcomes at all. So what that looks like in terms of a Venn diagram is something like this. Right? There's no overlap. It doesn't occur. So imagine a scenario where we're rolling die. Okay, so you've got your 1, you got 2, I don't know how many, you got 4, and so on, right? So like, let's call event A, rolling an even. And event B is rolling an even number, rolling an odd number. Well, the chance that you roll an even number or an odd number, that's 100%, because you're either going to have an even or an odd number for rolling a die. But these two things cannot occur at the same time. You can't roll an even and an odd with one die. So these are disjoint. A and B are disjoint. Or we'll call it mutually exclusive, because they don't share any common outcomes. Now, if I said, rolling an even number, and B, let's say rolling a multiple of 2, or a multiple of 3, excuse me. Now these are no longer disjoint. These actually share something in common, and so you would say these are not disjoint. These are, they have something in common, so therefore A intersect B does exist, because an even number that's a multiple of 3, well, that would be a 6, right? We can get a 6 out of a die. So there is something that does happen between the two of these to make them not disjoint.